Atomic clocks. Meet Bob.
Hi, I'm Bob.
He lives in 2000 BCE and he wants the latest in communicative technology, the carrier pigeon.
I want the newest carrier pigeon.
Bob uses a sundial to tell the time, and so he's very late for the opening of the carrier pigeon.
I'm very, very late.
This is because sundials are only accurate to the nearest hour. Meet Jim Bob.
Hi, I'm Jim.
He was born in 1930 and is a relative of the original Bob. Bob wants the latest in communicative technology, the rotary phone.
I want the rotary phone. Really bad.
In order to get to the opening on time, he uses a pendulum clock.
I use a pendulum clock.
However, this means that he's very late for the opening. This is because they are only accurate to the nearest minute.
Meet Jim Bob from 2017.
Hello!
Bob wants the latest in communicative technology, the iPhone 7 Plus.
I want an iPhone 7 Plus.
Bob uses a quartz watch to tell the time. Bob is late to join the queue for the iPhone 7 Plus because quartz watches are only accurate to the nearest second.
Oh no!
Meet Rim Jim Bob from 3000.
Hello!
Bob wants the latest in communicative technology, the iPhone 3012 Plus.
I want the iPhone 3012 Plus.
Bob uses an atomic clock to tell the time. Bob is on time to join the queue for the iPhone 3012 Plus opening. Bob is at the front of the queue.
Hooray!
This is because atomic clocks are nearly always on time.
This is not what an atomic clock actually looks like.
So then what is an atomic clock?
All elements vibrate naturally at different frequencies, sometimes called the natural frequency or resonant frequency. Cesium atoms vibrate at 9,192,631,770 times per second.
Why choose cesium atoms? All of its 55 electrons, except from the outermost, are confined to orbits in stable shells. This means that the outermost electron is not disturbed much by the others.
Cesium atoms are not normally vibrating, but when hit with their natural frequency in a wave,
Pew!
they will vibrate a lot. These vibrating atoms can be used to control the frequency of radio waves emitted from an electronic oscillator. These radio waves are then fired back at the atoms. Provided the frequency of the waves is correct, it should be the same as the resonant frequency of the atom. The electrons will be provided with enough energy to jump an energy level, making them vibrate further. Seconds can be measured by counting the amount of vibrations made. This keeps the clock very accurate.
So, the Bob family will never be late ever again.